So when you create an instance of a class, the Common Language Runtime will actually create an instantiation chain. Every class in the entire hierarchy from your subclass all the way up to the class object will be instantiated when your class is instantiated. This instantiation chain allows each individual element to call into its parent. It's important that each chain is individual and separate, because each chain may actually be maintaining its own instance data. So this gives you kind of a different way of looking at things. When you create an instance of a class in C#, you are always creating at least two objects: your base class itself and class object. Okay? Because remember that every class derives at some level from object. However, if your class were to derive from another class which derives from object, then when you create an instance of your class, it actually creates an instance of three classes. As in this example, assume that we have class B, which derives from class A, and A implicitly derives from class object. That means that when I create an instance of class B, I'm actually creating an instance of three different classes: class B, class A, and class object. Now, how does this chain actually get created? Well, remember that every single class has a constructor. So in order to create the chain, the Common Language Runtime will implicitly call the constructor of the parent class. This makes some assumptions, though, on the organization of the constructor. Every derived class will therefore implicitly call the default constructor of its base class. Remember that that default constructor is the one that doesn't accept any parameters. Now, as long as there is a constructor that doesn't accept any parameters in the class that you're deriving from, then you don't have to worry about creating any explicit calls yourself. Everything will work out just fine. But let's assume for a second that you had a base class that did not have a zero parameter constructor. Remember that if you create any constructor of your own, the compiler will not create a zero parameter constructor for you. So if you derive a class from that base class, and that derived class attempts to call the zero parameter constructor of the base class, what happens? Well, if that zero parameter constructor doesn't exist, then that's going to cause a problem. So what we would need to do then in our derived class is, using a keyword called base, we need to call a specific explicit constructor of that base class. Now, if that base class does not have any accessible default constructors available, then you basically must make some sort of explicit call in order to get this to work out. If for some reason there are no callable, there are no accessible constructors at all, then you've got an instantiation problem here.